Now see, there is one button in the bottom to present now. Present now, like you can turn on your camera, turn off your camera, you can mute yourself. In the same row there is one button to present now. Yeah, click on present now, then click on entire screen. Now select the screen, and now click on share. Yeah, now your screen is visible. Just open the PDF. Is the screen visible, guys, for all? Yes, now I am also able to see your screen. Can you zoom it little bit? Here on the top, see there is one button to zoom in, right? Just zoom this one. Yeah, yeah, click there. It's not working, leave, no problem. Yeah, it's visible. It's visible. Go ahead. So what is rot reflector? Here you can see. Actually, you know, rot reflector, we come up with rot reflector for IBGP only. Whenever we have lots of routers in the internal network, and we have, you know, full mesh topology, full mesh IBGP neighbor. In that scenario, what will happen? All routers will share routes information to other routers, right? So same problem like OSPF. In OSPF, why we come up with DR and BDR? The rot reflector is similar like that. Yes, now you can start reading from here. Hello. IBGP neighbor. Good. Yeah. Route reflector. Route reflector. CPU utilization of router. Very good. Great. Yes. At the same time, I am expecting that you are also getting the point, right? And you all are getting the point. If anyone have confusion with in any point, right, with any words, you can raise your hand. You can speak. Yes, Santosh. Go ahead. No, you will not share the ES number now for IBGP neighbor. Router never include ES number in the update for IBGP neighbor. by default, see, by default all routers in IBGP is server and their neighbors are non-client. Getting noise from your side, Santosh. And their neighbor are non-client. So the rule is, do not send the prefix received from a non-client neighbor to other non-client neighbor. Yes, Behzad, am I right? Yes, Santosh. Yeah, Behzad, now you can move. Correct. If anyone want to add the extra point here, you can add. Most welcome, most welcome, bro. And see, the my responsibility is to make you familiar with these all topics, right? So that you can crack interview. So definitely I have to share some time, questions with you, and you have to share answer in the live class. And we all are like-minded people. We all belongs to the same domain. So it is very important to make one connection, a strong connection, right? A relationship with each other. Yeah, go ahead. Great. Yes, yes, great. Exactly. You need to perform lab by yourself, right? Every time, whenever we are talking any topic, we are covering any topic, any lab, unless you will not perform by yourself, you will not feel confidence on that topic, right? Once you will perform the lab and you will see, okay, everything is working fine. All users are able to communicate with each other, like LAN to LAN communication is there. You will feel the confidence that yes, now I can configure it. I have understood it. So if interviewer will or anyone will ask you the question, right, you can answer them easily with confidence. So that's why it is very important to perform lab by yourself. Yes, Behzad, can you now scroll down the PDF? That PDF? There is one example as well. Yeah. Now even you can zoom it. Yes. Ro- Rot. When I'm saying rot reflector, that means I'm talking about the rot reflector server. Okay, yeah. Now see, there is one example of a company of a large enterprise network. Correct. Got it? Good. Go ahead. Okay, so guys, you guys can also review this PDF, and now let's begin the today topic. Okay, so Behzad, now you can stop sharing your screen. Now I am going to share my screen, and now focus on indirect neighborship in BGP. Indirect neighborship means if two routers are not directly connected with each other. Fine. Is my screen visible? Please confirm. Yes. Now let's suppose router 1 and router 2. This I have two router 1, router 2. Guys, between router 1 and router 2, there is ISP, any service provider, right? Or let's suppose between router 1 and router 2, I have multiple path. So in this scenario, if I will configure BGP neighborship by using physical interface IP address, then what will happen? If the physical link will goes down, then BGP session will goes down. Yes or no? If the physical link will goes down, let's say here IP address is 12.1, here IP address is 12.2. If I will say here router 1, your neighbor IP address is 12.1.1.2, right? So router 1 will send open message to 12.1.1.2. If I will say router 2, your neighbor is 12.1, it will send open message to 12.1, and then both router will form neighborship on this physical link. If this physical link will goes down, neighborship will goes down. You have to configure again, you have to change the neighbor command. This time let's suppose here IP address is 23.1, 23.2. So now again you have to configure neighbor 23.2 and order number 2 neighbor 23.1. Again, if this link will goes down, your BGP session will goes down. You have to change the neighbor command. So this is the problem. So whenever we have multiple path between the routers, what we can do, guys, I can create one loopback here, 1.1.1.1, here 2.2.2.2, and I can form BGP neighborship between 1.1.1 and 2.2.2. The benefit, if this link will goes down, still there is connectivity between 1.1.1 and 2.2.2, means BGP neighborship will be still there. If two link will goes down, no problem, still we will have BGP session, right? So BGP session depends on the best path between router 1 and router 2. That is called indirect neighborship in BGP. Now there are some new concept in case of indirect neighborship. So let me do one thing, let me perform lab as well at the same time. So here let me delete it. I'm going to delete this one as well, this one, then let me delete these routers as well here. For now I am not going to use it, or let me delete everything. Let me use to new router here, R1 R2. Now see, if I will for BGP neighborship between loopback on router number 1 and router number 2, then guys TTL value should be more than 1. TTL value should be more than 1. Here ES number is 100. For now I'm going to configure indirect neighborship in case of IBGP, right? ES number is 100 on both router. Here IP address is 12.1.1.1. Here IP address is 12.1.1.2. IBGP neighborship between router 1 and router 2. Let me turn on the device, and on router number 1 I'm going to create one loopback. That loopback is 1.1.1. Now you tell me, if 1.1.1 want to send some message to 2.2.2, can it router forward that message with loopback, with TTL value 1? Can router 1 send message to 2.2.2 from 1.1.1 with TTL value 1? No, right? TTL value should be minimum 2, correct? So see guys, what is happening in case of eBGP, there is one rule. That rule is known as directly connected check rule, right? Means routers check directly connected rule, and by default directly connected rule is enabled in case of eBGP, and it is disabled in case of IBGP. So in case of IBGP, if ES number is same on both router, right, directly connected rule is disabled. That means these routers can form neighborship between 1.1.1 and 2.2.2. But in case of eBGP, if I will configure here ES number 200, so in case of eBGP, by default directly connected rule is enabled, right? So 1.1.1 and 2.2.2 is not directly connected, so in that scenario you have to disable the rule. This is a new concept in case of indirectly connected neighborship. Now let me do one thing, let me access this router and let me configure, enable the BGP first. R1. Yeah, recording is on, bro. Thanks. Interface F0/0, say no such, and IP address 12.1.1.1.255.255.255.0. Interface loopback 1, IP address 1.1.1.1.255.255.255.255. On router number 2, interface F0/0, no such, and IP address 12.1.1.2, 12.1.1.2, 255.255.255.0. Exit interface loopback 1, and IP address is 2.2.2, 255.255.255.0. Done. Hope the issue is clear. Like between router 1 and router 2, if I have two link, one more link, 1/1, this is upper link is 0/0 and the lower link is 1/. So why we should not configure BGP with the help of physical IP address here? See the issue. Let me do one thing to make it more clear. What I can do, I can configure the scenario. I can configure BGP neighborship on physical link. So here IP address is, let's say, 21.1.1.1, and here IP address is 21.1.1.2. Yeah. So on router number 1, let me configure one more IP interface f1/0 say no set and IP address 21.1.1.1.255.255.255.0 exit interface f1/0 no set and IP address 21.1.1.2.255.255.255.0. Now to verify connectivity, I am going to ping from router 1 to router 2, 12.1.1.2. See, ping is working, right guys? And ping 21.1.1.2. Ping is working. See, between router 1 and router 2, what I am going to do, I am going to configure any IGP protocol. Why IGP protocol? To make reachability between 1.1.1 and 2.2.2. See, if I am going to say router, your neighbor is 2.2.2 to router number 1. So router 1 is going to send open message to 2.2.2.2. So there should be route in the routing table, yes or no? If there is no route, then router cannot forward open message. Even router cannot establish TCP connection. Right? So I am going to configure any IGP protocol to make reachability between 1.1.1 and 2.2.2. Will not advertise prefixes in IGP protocol. Why we will not advertise prefixes in in IGP protocol? Let's suppose router 1 have 10,000 prefixes, router 2 have also 10,000 prefixes, and they need to exchange this route between router 1 and router 2. So can IGP protocol handle, guys, 20,000 prefixes? No. IGP routing protocol cannot handle 20,000 prefixes. So I will exchange these prefixes with the help of BGP, right? So for route exchange here, I am not going to use IGP protocol. I am using IGP just for internal reachability. For internal reachability. So let me do one thing. Which IGP protocol you want to configure, guys? EIGRP, RIP, OSPF. Which one? Tell me any IGP protocol. OSPF. Yes. In the real time also I am always using OSPF. So let me say router OSPF 1 and then router ID is 1.1.1. Then network I can say 0.0.0 255.255.255.255 to advertise prefixes in to enable OSPF on all interfaces. In the same way on router number 2, a router OSPF 1 and router ID 2.2.2.2 and the network is 0.0.0 255.255.255.0 area 0. By the way, we should not advertise prefixes like this, like 0.0.0, and in real time also you will not advertise prefixes like this, because guys, see, when I will add some more loopback here, right, that so automatically OSPF will enable there, and router will prefer BGP or OSPF here for the best path selection. What is the issue? OSPF invalid address 0.0.0 255.255.255 sorry .255 255. Soon OSPF never will come up. Yes, now you can see, right? But if I will create any loopback here, if I will add any LAN here, automatically OSPF will advertise that LAN in IGP, right? So let me do one thing. Let me remove this network command. Say no to this network command, and I am going to do one thing. Enable OSPF on interface basis. Interface range f0/0, f1/0, and then loopback 1. On these interfaces, I am going to enable OSPF. IP OSPF 1 area 0. Done. On router number 2 also, say no to this command, and then what happened? Router OSPF 1 and no to this command, then interface range f0/0 f1/0 and loopback 1. IP OSPF 1 area 0. Done. So IP OSPF interface brief. Now you can see OSPF is enabled on these 3 interfaces. On router number 2 also, so IP OSPF interface brief. OSPF is enabled on all interfaces. So IP OSPF neighbor. Done. So we have neighborship on both link, correct? On router number 1 also, so IP OSPF neighbor. And see the routing table, so IP route OSPF. So this router is learning 2.2.2 and router 1 is performing what guys? Load balancing, correct? In the same way router 2, so IP route OSPF. It is learning 1.1.1 and it is performing load balancing. So in this scenario, now I have some more loopback interfaces. First of all, we can do one more thing here. Router OSPF 1, we can say passive interface loopback 1 to stop OSPF message on LAN interface. Here also I can say router OSPF 1 and passive interface loopback 1. Now this is the stable OSPF configuration. Still this is not much stable. What we can do, we can change the network type on interface range F0/0 and F1/0. I can say interface range F0/0 and F1/0. What I can say, IP OSPF network point to point. Do so history. I can copy this command and let me paste this command on router number 2 also. Done. Now OSPF network is completely stable between router 1 and router 2. Now you can verify the connectivity, ping 2.2.2.2 and source 1.1.1.1. Now let me do one thing. Let me create some LAN network here. Like router 1 is connected with, let's say, 10.1.1.0/24 and router 2 is connected with 20.1.1.0/24. 20.1.1.0/24, and I am going to advertise this network between routers through BGP routing protocol, right? So router BGP S number 100 and neighbor 12.1.1.2 and remote AS is 100 and the network command 10.1.1.0 mask 255.255.255.0. Done. Go to router 2, router BGP S number 100 and say neighbor 12.1.1.1 and remote AS is 100 and then network 20.1.1.0 and mask 255.255.255.0. Now we have BGP neighborship, so IP BGP summary. Done. On router number 2, so IP BGP summary, correct guys? And so IP BGP, there is no any prefix in BGP table, so IP route is 10 network there. I have not added the loopback. Interface loopback 10 IP address 10.1.1.1 255.255.255.0. On router number 2 also interface loopback 10 IP address 20.1.1.1 255.255.255.0. Done. Now tell me the issue. What is the issue here? So IP BGP. Now you can see the BGP table. It have both network, right? And next up is 0.0.0 for self advertise prefix. So IP BGP, right? Both router have installed both network in BGP table. So IP route BGP, it have installed 10 network in their routing table. Router 2, so IP route BGP, it have installed 20 network. Everything is working fine and these two LAN can communicate with each other, ping 20.1.1.1 and source 10.1.1.1. Which path router 1 will use to forward traffic in 20 network from 10 network? Which path it will use, guys? So IP route BGP, you can see 12.1.1.2 because BGP neighborship is on upper link. Now the issue is if upper link will goes down, if ISP1 will goes down, let's suppose upper link is ISP1, F0/0 shut down, right? What will happen? BGP neighborship will goes down. So IP BGP summary. Now you can see, just wait for some time. Clear IP BGP and so IP BGP. So IP BGP summary. Neighbor is idle. But guys, there is still connectivity between router 1 and router 2. Ping 2.2.2.2, source 1.1.1.1, right? There is a still connectivity. But BGP neighborship is done. So IP BGP summary, correct? Round router number 2 also. So IP BGP summary. BGP neighbor is idle. These are state, idle, active. Don't worry, we will discuss these things later. Now, so IP route. We don't have 10 network, 10 subnets here. On router number 2, so IP route, we don't have 20 subnets. So between router 1 and router 2, we have 2 ISP. One ISP is, let's say, Airtel, another ISP is Tata Communication or BSNL. Any ISP can be there. So guys, in this scenario, we will not configure BGP with the help of IP address which is running on physical interface. Done. See the second method, indirect BGP neighborship. Router BGP number 100 and no neighbor 12.1.1.2 and remote AS is 100. I have removed the neighbor command. Router BGP number 100 and no neighbor 12.1.1.1 and remote AS is 100, right? Now on router number 1, neighbor 2.2.2.2 and source, sorry, 2.2.2 remote AS 100. On router number 2, neighbor 1.1.1.1 and remote AS of neighbor 100. Done. I have configured it. But will neighborship come up? So IP BGP summary. Neighbor is idle. Now tell me guys the reason why neighbor is idle. Tell me the issue. Huh? Ping is working. I am able to ping 2.2.2, 2.2.2, source 1.1.1.1. But the issue is, guys, see, virtual link, where is the virtual link? See what I have configured here, neighbor 2.2.2 and remote AS 100. So what router 1 will do? Router 1 will generate SYN message for the neighbor. Source port will be random port number, destination port number will be 179. Source IP will be the neighbor IP address 2.2.2. Sorry, destination IP address will be 2.2.2 neighbor IP address. And what will be the source address? What will be source IP? Source IP. Source IP 12.1.1.1. How router will find source IP? Router is going to check routing table. So IP route and neighbor is 2.2.2. So for 2.2.2, what is the next of IP address? 12.2 and 21.2. So two path is available in the routing table. Two path is available in the routing table. Actually OSPF is doing what? Load balancing. So IP both interfaces are up. This interface is down here. That was the previous entry, I think. No set. I have enabled it on now. So IP route for 2.2.2 next hop is 21.1.1.2, right? And for 21.1.2 exit interface is fast ethernet 1/0. So guys, source IP address will be the IP address which is running on exit interface. So source IP is what? Source IP 21.1.1.1, or it can be 12.1.1.1 if upper link is up. Now it will forward, router 1 will forward this SYN message to router number 2. router 2 will receive at layer 1. It will hand over to layer 2. Layer 2 will check destination MAC. Then it will hand over to layer 3. Layer 3 will check destination IP. Destination IP will match. It will hand over to layer 4. Layer 4 will see, okay, that this is the BGP message, right? Destination port is 179. Let me generate SYN plus ACK. And this time router 2 will generate SYN plus ACK for which IP address? For which destination? 12.1.1.1. But who is the neighbor of router 2? 1.1.1, not 12.1.1.1. So here router should set what source? 1.1.1 instead of 12.1.1.1. Here source should be 1.1.1.1, correct? So manually I have to tell to router 1, bro, please update source IP address. So what I can do, I can say router BGP number 100 and your neighbor is 2.2.2.2. For this neighbor, do one thing, please update source address. And what will be the source address? The IP address which is running on loopback 1 interface. Getting my point, guys? Now you can see BGP neighbor is up. Done. In the same way on router number 2 also, I have to configure neighbor 1.1.1.1 and update source loopback 1. I have updated the source IP address. Now both routers are going to send open message and SYN message with source address what, which is running on loopback 1 interface. So now show IP BGP summary. Now you can see we have BGP neighborship and it have received one prefix from their neighbor. So IP BGP, see the BGP table, fine. So IP route BGP, yes, it have installed 20 network. And on router number 2, so IP route BGP, yes, it have learned 10 network. Again these two subnet can communicate. Ping 20.1.1.1 and source 10.1.1.1. Ping is working, so IP route BGP. And you know, this time router is performing load balancing. Why it is performing load balancing? Because see the next hop IP address for 20 network. For 20 network, next hop IP is 2.2.2.2. 2.2.2, and for 2.2.2, two paths are available in the routing table. So IP route, yes, for 2.2.2 you can see two paths is available. Now if upper link will goes down, let's say fast ethernet 0/0 interface f 0/0, do you think BGP neighborship will goes down, guys? Clear IP BGP star. Will BGP neighborship goes down? So IP BGP summary, no, right? Because one path is still available here. So this is indirect BGP neighborship in case of iBGP. So we don't have any problem here. We only need to configure update source command for the neighbor, correct? Now interface f 0/0, again I am going to say no shutdown, and trace route 20.1.1.1 source 10.1.1.1. It is forwarding traffic to both neighbor C, correct? It is performing now load balancing. Done, guys. Now see the indirect neighborship in case of eBGP. So for eBGP, what I am going to do, I am going to configure ES number 200 here. 200. Any question in iBGP? In indirect neighborship in case of iBGP, any question, guys? Any question? Please ask. Yes. Surya, is it clear? Santosh, Surya, Ganendra, Behzad, Hemnath, Parveen. Yeah, if both ASP is down, then definitely this connectivity will go down, BGP session will goes down. But there is very less chance, bro, that both ISP will goes down at the same time. Yes or no? Or for the better reachability, for the better redundancy, what we can do, we can add one more link. Clear, Santosh? Hemnath? Parveen? Siddhu? Sindhu? Yeah, go ahead. Yeah. To make reachability between these two, loop back to 1.1.1 and 2.2.2. Bro, router 1 don't have route now for 2.2.2. By default, router install only directly connected network in their routing table, right? So router 1 will have this network, and this network, and this network in their routing table. Router 2 will have this network, this network, this network, and this network in routing table. Only directly connected networks. So either you can configure a static route or any IGP protocol here to share 1.1.1 to router number 2 and 2.2.2 to router number 1. You cannot configure default route. BGP will not consider default route. In eBGP also, reachability must be there between 1.1.1 and 2.2.2. You have to configure IGP protocol. See, in real time, how we are using BGP, guys. See, at the same time, you will be using both routing protocol, IGP as well as EGP. IGP for reachability, for internal reachability, not to share routes, routing informations. To make reachability between 1.1.1 and 2.2.2, I will be using IGP protocol. Even service provider will be using IGP protocol in their internal network. Like this is service provider network. R1, R2, R3, R4, R5. This service provider have customer, one customer over here, customer A, and one customer over here. To share customer A side 1 and side 2 prefix, side 1, side 2 prefix between each other, what ISP will do, ISP will form one BGP neighborship between PE to PE, PE to PE. Again, ISP will not use physical interface IP address because there are multiple paths available. So what it will do, it will create one loopback here 1.1.1 and here 2.2.2. And to make reachability between 1.1.1 and 2.2.2, it will use OSPF routing protocol. In the same mail, this service provider have one customer over here, customer B side 1, and one customer over here on router number 4, let's say side 2. Again, see, between router 3 and router 4 there are multiple paths. One path is this one path is this one path is this one, and one path is this one, right? So it will not form BGP neighborship with the help of physical IP address. It will create one loopback here 3.3.3 and 4.4.4. To form BGP neighborship between 3.3.3 and 4.4.4, what this service provider will do, this service provider will use IGP protocol. And once 3.3.3 and 4.4.4 are reachable with each other, it will form BGP neighborship here to share company prefixes, customer prefixes. And same thing I am doing here. I am sharing this 10 prefix and 20 prefix with the help of BGP, right? And I am running IGP protocol to make reachability between these two loopbacks. Got it? Any other question, guys? Even you can configure a static route. Why we need to run update source loopback 1 command? Because by default router will send BGP, send message or any message to their neighbor with source of exit interface IP address. Now let me configure eBGP here. On router number 2 I am going to say no router BGP S number 100, and on router number 1 I am going to remove neighbor command router BGP S number 100 and do so run BGP section BGP. I am going to remove all neighbor commands here. This one update source loopback one, say no to this and no to this. Neighbor 2.2.2 remote yes, this one. Now on router number 2 I'm going to run ES number 200. So router BGP ES number 200 and neighbor 1.1.1.1 and remote ES of neighbor is 100. Network 20.1.1.0 and mask 255.255.255.0. So IP BGP tab install 20 network fine. R1 router BGP ES number 100 and neighbor 2.2.2.2 and remote ES of neighbor is 200. Network is already here, so IP BGP. Yeah. Now will BGP neighborship come up guys here? Just a minute. Just tell me what is the issue? Why there is no BGP neighborship? So IP BGP summary neighbor is idle. On router number 2 also, so IP BGP summary neighbor is idle. So TCP brief, there is no any TCP connection. So TCP brief, no any TCP connection. Why? Why guys? Debug IP BGP debug BGP I can say all for all address family, for IPv4 address family, debug IP BGP and all address family. What is the command guys? We had used update message. Done. I have enabled the debugging. Is router 1 sending any BGP message? BGP 2.2.2 active open failed. You will learn this while neighborship state. Let me do one thing. Debug IP TCP transaction. IP TCP transaction. Or even you can capture the link between router 1 and router 2. Debug IP TCP yes. Now you will see the SYN message. So IP route 2.2.2 is there. Yes, 2 path is available. This is hello message of OSPF. Where the SYN mass is. Why I'm not able to see any SYN message here on daughter 2? So run section BGP. Never wonder on remote. Yes, fine. We are not able to see the SYN message, but both routers are sending SYN message with source exit interface IP address. So the issue is, guys, so IP BGP summary. In the simulation, it's not showing the SYN message here. Don't worry, leave it for now. Why neighborship is idle? Because we didn't configure what? Update source loopback 1. And the second thing, why you are not able to see the SYN message? Because of directly connected. This is not problem of simulation software. This is just because of directly connected rule. Because of directly connected rule. For IBGP, router send TTL value 255. For eBGP, router send TTL value 1. Right? So when router 1 will generate the SYN message, it will generate SYN message with what TTL value? 1. And router 1 itself drop that SYN message. So IP BGP, okay, this is self-advertised prefix. So IP BGP summary neighbor is idle. So in eBGP, directly connected rule is enable, and in case of IBGP, directly connected rule is disable. So by default, eBGP can be configured on directly connected link only. We cannot configure eBGP on indirectly connected network, indirectly connected link, we can say. So in this scenario, actually we need to disable that rule. To disable that rule, we can run one command here on router number 1. I can say router BGPS number 100 and your neighbor 2.2.2.2. I'm saying for this neighbor, please do one thing, disable the connected check rule. Right? Once I will disable the connected check rule, now you will see the SYN message. Are you able to see SYN message, guys? Are you able to see the SYN message? Yes. But router 2 is sending what? Reset message. The reason? See the source IP address 21.1.1.1. Source IP address is 21.1.1. And even router 2 is sending reset message to which IP address? 21.1.1. Got it? So one more command here I need to run, that is neighbor 2.2.2.2 and update source loopback 1. Now wait for the next SYN message. This time you can see the SYN message. Source 2.2.2, destination 1.1.1. Now, so IP BGP summary, still neighbor is idle. Because guys, still router 2 is sending this SYN message with TTL value what? 1, because directly connected rule is still enable on router number 2. So if you will open this SYN message, router 2 is sending TTL value. Where I will find the TTL value? In which header? In IP header or TCP header or Ethernet header? Layer 3 means IP header. What is the TTL value? 255. Which message it is? It is acknowledgement message actually. Where is the SYN message? Is there any message of 1.1.1? Router BGP number 100. And let me do one thing for now. Just I'm going to say no to this command. I have removed this command. Now if you can see any message, any SYN message here. By the way, now router will not send SYN message. Actually what is happening, router 2 is sending SYN message, not SYN message, acknowledgement message to router number 1 with TTL value 255. Reset message, this one is reset message. What we can do here, we can open this one and then flag. This is which type of message it is? Reset message. So that's why TTL value is 255. That's why TTL value is 255. Let me do one thing. Here we can note, see the exact output, neighbor 2.2.2 and disable connected check on router number 2 also. Router BGP AS number 200 and neighbor 1.1.1.1 and disable connected rule. Now we have BGP neighborship. Now I have disabled it. Now see the TTL value guys here. TTL value is 1. So now we have BGP neighborship. So IP BGP summary. We have BGP neighborship and so IP BGP. Now everything is working fine. So in case of actually eBGP in directly connected neighbor, you have to disable directly connected rule. But here we are not able to see the correct output. How you can understand this? Always keep in mind that BGP router sends their messages with TTL value 1 to their eBGP neighbor and with TTL value 255 to their iBGP neighbor. What you can do guys, you can connect two router together. You can enable the BGP, iBGP and eBGP both. First enable iBGP and capture the link and check the TTL value. Then configure eBGP, then capture the link and check TTL value. So in this scenario we had two problems. Number one, directly connected check rule was enabled, right? So I have disabled it. The second problem was TTL value 1 for eBGP. So to increase the TTL value, what we can do here, config T, still you can see the TTL value is what? 1. Where is the BGP update message? Here. In the update message, who is sending? Router 2. TTL value is what guys? 1. So this time router 2 can send the update message to router number 1 with TTL value 1, right? But if there is another router, let's say router number 3, so can router 3 send a prefix to router number 1? No, because in this scenario we need TTL value minimum 2, right? So you can connect one more router here. You can connect one more router here to verify that. And to configure TTL value, command is very simple. Like here I can say router BGP number 100, and again then neighbor. Whatever command I am applying, whatever features I am enabling or disabling, right, I am doing for a particular neighbor, right? Every time I am saying first neighbor 2.2.2. For this neighbor, do one thing: enable BGP multi-hop, configure EGP multi-hop, and this is the TTL value. What is the range? 1 to 255. By default for eBGP, TTL value is 1. Here I can configure what? 2, 3, 4, anything. In my scenario, I have only 2 router, but let's suppose what I can do, I'm going to add one more router here, guys. Let me clear your concept. R3 here, right? And I'm going to configure loopback here 3.3.3.3. Now I will form BGP neighborship between router 1 and router 3, between 1.1.1 and 3.3.3. I'm going to disable BGP from router number 2. Even I'm going to delete one link here. It's not required. On BGP, on router number 3, I'm going to run BGP number 200. Will disable BGP from router number 2. Here IP address is 21.1.2, and here IP address is 21.1.3. This is my scenario, let's say, and here I have subnet 30.1.1.0. So on router number 2, first of all, let me say no router BGP number 200, no router BGP number 200, and guys, no interface loopback 1 and no interface loopback 10. So IP interface brief. You can see I have removed the loopback. On fast Ethernet 1/0 IP address is 21.1.2. That is correct. And so IP OSPF interface brief. You can see OSPF is enabled on both interface. Now let me take you to R3 directly, and on R3 let me configure the IP first. Config T, yeah. Okay, let me correct it. Yeah, sure. Then interface loopback 1 and IP address 3.3.3.3 255.255.255.255, and interface loopback 10. Here I am going to run LAN network, which is 30.1.1.1 255.255.255.0. On router number 2, loopback IP address is incorrect. Correct. So here I can say no, sorry, interface F1/0, no IP address, and shut down. Exit interface F1/1, say no shut, and the IP address 21.1.1.2 255.255.255.0. Interface F1/1 IP OSPF 1 area 0. Now can I ping router 3 from router number 2 21.1.1.3? Ping should work, and ping is working. So IP OSPF interface brief. OSPF is so IP OSPF interface brief. OSPF is enabled on both interface. On router number 3, router OSPF 1 and router ID 3.3.3.3. Exit interface range F0/0 loopback 1 and loopback 10. IP OSPF 1 area 0. Now let me verify the connectivity between 1.1.1 and 3.3.3. Ping 3.3.3 and source 1.1.1. Ping should work. Let me troubleshoot the issue, guys. Ping 12.1.1.1 router 1. I'm not able to ping R1. So IP interface brief. What is the issue here? IP is correct, but their line protocol is down on router number 2. So IP interface brief. Line protocol is down means F1/0 is down. Actually here this is not 0/0. Let me correct the configuration. Interface F1/0 say no IP address and shut down. Then exit interface F1/0 IP address 12.1.1.2 255.255.255.0. It's overlapping. Do so IP interface brief on 0/0 their interface F0/0 say no IP address and shut down. Interface F1/0 IP address 12.1.1.2 255.255.255.0. Still there is some issue on router number 1 because this IP address is running on F0/0 but it should be run on 1/0. Interface F1/0 no IP address. I was removing upper link but by mistaken I have removed the lower link. Shut down. Exit interface F1/0 and IP address 12.1.1.1 255.255.255.0 and no shut. Now I think everything is fine. Again here IP address is overlapping. Interface F0/0. Do so IP interface brief. So still IP address is there. Don't know why it's happening. No IP address and shut down. Interface F1/0 IP address 12.1.1.1 255.255.255.0 and no shut. No router BGP number 100. So IP interface brief. Now everything is correct, right guys? So from router number 2 let me ping again to 12.1 and this time ping should work. Still ping is not working. So IP interface brief 12.1 their line protocol is up, everything is up on router number 2. So IP interface brief on F1/0 12.2 interface F1/0 no shut. Now ping is working and so IP OSPF neighbor. So we have OSPF neighborship now. So IP route OSPF. So you can see we have 3.3.3. So ping 3.3.3.3 and source 1.1.1.1. So ping is working. Now I can form BGP neighborship between 1.1.1 and 3.3.3. Now I am not going to configure anything on router number 2. Let me close the console of R2. There is no any role of R2 here. R1 router BGP AS number 100 and neighbor 3.3.3.3 and remote AS of neighbor is guys 200. Then neighbor 3.3.3.3 update source loopback 1 and neighbor 3.3.3.3 disable connected rule. Done. And network 10.1.1.0 mask 255.255.255.0. Same thing I need to do on router number 3. So router BGP AS number 200 and neighbor 1.1.1.1 and remote AS of neighbor is 100 neighbor 1.1.1 update source loopback 1 and neighbor 1.1.1 disable connected check. Now why we don't have neighborship? So IP BGP summary. What is the issue? Why neighbor is idle? Because of TTL value. because of TTL value. Are you able to see the SYN message? In the SYN message, TTL value is 1. Even you can open any message, router 1 is sending this one, TTL value is 1, right? So this message can reach up to router 2 only, right? So in this scenario, what we need to do, we need to configure eBGP multi-hop, right? So say neighbor 3.3.3.3 and eBGP multi-hop. What should be the TTL value? You can configure any value, guys, but for the security, you should configure 2 only, right? So you have to find the how many hop away neighbor is, how many hop away, right? That should be the TTL value. So TTL value should be here 2. Once I will configure TTL value 2, you can see the here now router 1 message. Yes, 1.1.1 is sending the SYN message now. Let me open this SYN message. TTL value is now what? 2. Correct? Here is the TTL value here, right? TTL value is, guys, now 2. But still we don't have neighborship. Reason? Router 3 is still sending SYN message on TTL value what? 1. Router 3 is still sending their SYN message on TTL value 1. This is why you are not able to see the SYN message of router 3 on this link. Because router 3 will send SYN message with TTL value 1 to router number 2, and router 2 is going to discard it, right? So we will not find any SYN message of router 3 on this link. But once I will set TTL value 2 on router number 2, how to configure? Router BGP as number 200 and they say neighbor 1.1.1 eBGP multi-hop 2. Now you can see the neighborship is up. Here is the SYN message of router 3. TTL value is, see, this is incorrect information. You can open the new message 3.3.3. Okay, TTL value is 1. Correct. Why TTL value is 1? Because I am capturing this link, right? So router 2 will decrement TTL by 1. Correct. So router 3 is sending SYN message with TTL value 2. Router 2 will decrement it by 1. So TTL value will become 1 on this link, right? And now we have BGP neighborship between 1.1.1 and 3.3.3. So IP BGP summary, fine. And see, both have exchanged the route. So IP BGP summary. I think on router number 3 I have not advertised the LAN. So IP interface brief. Yeah, loopback is there. A router BGPS number 200 and network 30.1.1.0 mask 255.255.255.0. So IP BGP. It have installed 30. Now it will share with router number 3. So IP BGP. Fine. Now question is, can 10.1 ping to 30.1? Ping 30.1.1.1 source 10.1. No, ping will not work. See, ping is not working. Why ping is not working? See, when I will ping to 30.1.1.1 from 10.1.1.1, destination source IP will be 10.1.1.1, destination IP will be 30.1.1.1, right? User will forward it to router 1. Router 1 is going to check their routing table. So IP route. Yes, 30 network is available in the routing table through BGP. From OSPF also it is receiving. So from R3, let me do one thing. So IP OSPF interface brief. I have enabled OSPF on loopback 10 as well. So interface loopback 10, no IP OSPF 1 area 0. Done. Clear IP route star. So IP route. Done, guys. Now I am learning 30 from BGP only, right? So router 1 will compare destination IP address in the packet with routing table. It will get to know, okay, next hop is 3.3.3. Who is advertising 3.3.3? So to forward traffic to 3.3.3, next hop is, or exit interface is fast Ethernet 1/1. So router 1 will forward this packet from fast Ethernet 1/1. Router 2 will receive it. Router 2 will receive it. Now router 2 is going to compare destination IP with their routing table. So IP route. Is route available, guys? 30 network in the routing table? No. So router 2 will discard it. So in this scenario, now I am going to configure MPLS between router 1, 2 and 3 to forward the traffic. We will configure MPLS service. Let's suppose this is a network of service provider, right? R1 is a PE router. R1 is a PE router. P1, P2. Right? This is PE router, provider router. So service provider have configured BGP neighborship between P1 to P2. It is exchanging route. Definitely P router, provider router will not install routes, because guys, customer can have 100k prefixes, right? So service providers are also going to use normal router in their network, right? Their PE routers are high configured router, right, with good RAM, good memory, but these routers are again normal routers who cannot install lots of prefixes in their routing table. So in this scenario, we'll configure MPLS. Don't worry, when we'll start the MPLS, you will understand how it's work. Interface F1/0, simply I can say MPLS IP. On router number 3, I can say interface F0/0 MPLS IP. And on router number 2, interface range F1/0 and F1/1 MPLS IP. Now these routers will form LDP neighborship. Here you can see the log messages, right? And now let me try to ping again. Ping 30.1.1.1 and source 10.1.1.1. See, ping is working, yes or no? Ping is working, but now you can see the routing table of router 2. So IP route. Is router 2 have 30 network guys in the routing table? No. So might be you are thinking that this is magic, right? But this is not magic. Actually, now the provider router number 2 is forwarding traffic with the help of label. Guys, comparing destination IP address in packet and forwarding traffic on the basis of routing table is traditional way of forwarding traffic. The newest way to forward traffic by a router is label forwarding. Like routers are forwarding traffic on the basis of label. Do you want to learn MPLS right now? See how easy MPLS is. Once I have enabled MPLS on these interfaces, what router have did? Router 1 have add one label to all the available route in the routing table, right? So router have one route in the routing table 10.1.1.0/24 and 130.1.1.0/24. So for both network, for all networks in the routing table, router 1 have added one label, right? Let's say label over here is 100, label over here is 100. In the same way, router 2 is also going to add one label to all routes available in the routing table, right? And router 3 is also going to add one label to all available routes 10.1.1.0/24. Let's say label is 400 and 30.1.1.0/24 label is 500. And guys, in the MPLS, all routers are going to form LDP neighborship, like BGP, like OSPF. All routers are going to form LDP. LDP is again one protocol, LDP neighbor, right? So these routers are going to exchange this table with their neighbor, right? So router 2 will advertise this table to router number 2. Router 3 will also advertise this table to router number 2. And router 2 is going to learn label for 10 network as well as for 30 network. right? So see, on router number 2, so MPLS, LDP, neighbor. So two peer, one is 1.1.1 and another one is 3.3.3. So MPLS forwarding table. Are you able to see label for 1.1.1 and 3.3.3? Yes. On the basis of this label, now router is going to forward traffic. Right, don't worry, we will understand MPLS, but again MPLS is also guys very easy, you can easily understand it, right? This is just a method to forward traffic on router, like you know how router forward traffic with the help of routing table. In the same way you will learn how router will forward traffic on the basis of label. That's it, very easy. So hope it is clear, and now you can see both LAN are able to communicate with each other. Even provider router don't have routes in their routing table. 10 and 30. Fine. Now let me do one thing. Let me create this network as completely real-time network. So for that, what I'm going to do, I'm going to remove again console of R2 here, and on R1 let me say no router BGP yes number 100, and on router number 3 say no router BGP yes number 200. Because guys, if this is service provider, then both service provider will have same autonomous system number, right? So let's say here also we have both autonomous system number S100. Let me stop the capturing because it's not required now. Now let's suppose this is a network of service provider. This is a network of service provider, and there are two customer, means two sides of one customer. Customer is, let's say, Dell. Who is the customer? Dell. There is one Dell customer. This is, let's say, side 1 of Dell, and this is side 2 of Dell. Autonomous system number is 100. See, in the service provider you will have lots of router, right? So right now I am going to connect two sides of one customer here, R1, R4 and R5, let's say. Fine. Here what subnet I have? Let's say 10.1.1.0. Here what subnet I have? Let's say 20.1.1.0/24. Now I am going to connect my customer network to service provider network. Let's say on F0/0 here and on 1/0 here. This is completely real-time scenario. Yes or no? What will happen in this scenario, guys? So let's suppose this is one customer, HP or Dell. Service provider is running AS number 100. AS 100 is running in service provider network. This is service provider. Service provider. So now you tell me, router 4 is which type of router? P router, C router, del side 1. Which type of router is router 4? Customer edge router, yes or no? Customer edge router. Router 1 is which type of router, guys? Del side 2. Del side 2. Router 1 is which type of router? PE router, provider is router. And in the customer side, let's say I'm running AS number 500. In the customer network, customer is using BGP AS number 500. Here also and here also. Done. This is the scenario. Now, which type of neighborship service provider is going to form between P to P? This is P, this is another P, right? They are going to form IBGP neighborship, correct, guys? IBGP, fine. So router, and here between P to CE, which type of neighborship we will have? IBGP neighbor. I'm sorry, EBGP. Extremely sorry. EBGP. Here also we will have EBGP, right? So router 4 is going to advertise this subnet to P router. Will router 4 include their AS number in the update? Yes or no? Yes, right? So it is advertising 10.1.1.0/24 and AS number is 500. Now P router R1 will install it in their BGP table, in their routing table. In the BGP table, this network will be best as well as valid. So it will advertise to their neighbor. Who is neighbor? 3.3.3. So router 1 is going to advertise 10 network to their neighbor to R3. Now tell me, R3 will include their AS number? Yes or no? No. Very good. /24. AS number will be only 500 in the update message. R3 will receive it. R3 will also install it in their routing table, in their BGP table first. In the BGP table, it will be best as well as valid, because next hop will be 1.1.1 for this network, and 1.1.1 is already reachable because of OSPF in the service provider network, correct? Now router 3 is going to advertise it to their other neighbor, means to router number 5. Will it include their AS number? 10.1.1.0/24, and there are not two AS number, 500 and 100. Now tell me, R5 will accept it or not? No. This is loop avoidance mechanism in case of EBGP. On router 5 will see their own AS number, which is 500. It will come to know, oh, this prefix is coming from same AS. It will discard it. In the same way, when router 5 will advertise this network to R3 P router will advertise to router number 1, other P router, then this P router will advertise to this C router, but this C router will discard it, correct? Let me configure it very quickly. This scenario, OSPF is already running in the service provider network, MPLS is already running, right? I only need to configure router 4, router 5, and the BGP on router number 1 and 3. So let me access these routers. What is happening here? Sometime it's irritating. Yes, on R4, config T, interface F0/0, no set, and IP address. Between router 1 and router 4, let me use 14 network. No set. And interface loopback 1, IP address 10.1.1.1 255.255.255.0. Then router BGP AS number 500, and neighbor is here we will not configure neighborship with loopback interface because I have only one link, correct guys, between C to PE. If I have only one link, then I will configure neighborship on physical interface. So neighbor is 14.1.1.1. Remote AS of neighbor is 100, correct? Any other command is required? No. Network 10.1.1.0 mask 255.255.255.0. Configuration of router 4 is done. So IP BGP. It have installed this network in BGP table. So IP BGP summary. Neighbor is idle. I didn't configure BGP on router number 1 till now. Don't worry. Let me configure first CE router, other CE router, site 2 CE router. Config T, interface F0/0. Between router 3 and router 5, I am going to use 35 subnet, 35.1.1.5, 255.255.255.0. Exit, interface loopback 1, IP address 20.1.1.1, 255.255.255.0. Done. Router BGP number 500, neighbor 35.1.1.3, remote AS 100, and network 20.1.1.0, mask 255.255.255.0. Done, guys. Done. C router configuration is done. Now let me take you to R1. On R1, do so IP interface brief. So 10 network is already running there. So say interface loopback 10 no. I have removed this interface. Now you can see it. 10 network is not there, right? Now let me configure the BGP. Router BGP number 100. Neighbor 3.3.3.3. Remote AS 100 same. Neighbor 3.3.3.3. Update source loopback 1. Then neighbor 14.1.1.4 and remote AS of this neighbor is 500. Correct? We are not going to advertise any prefix here, right? This is service provider network. Why we don't have neighborship? Interface F0/0 no cert and IP address 14.1.1.1 255.255.255.0. So IP interface brief, interface F0/0 is up, and so IP BGP. There is something wrong, guys, in BGP. See the notification message. So run section BGP. Router BGP number 100, neighbor 3.3.300, loopback 1, fine. Neighbor 14.1.500. On router number 3, let me router number 4. Let me verify the BGP configuration. So run section BGP 14.1.1.1, remote AS 100, and router BGP what AS number here I have configured 500, correct? (500) 14.1.1.4. What is the issue? Ping 14.1.1.4. So IP BGP. So IP BGP summary. Both neighbor are idle. So run section BGP. BGP is number 100, neighbor remote AS, correct? I think everything is fine here. On router number 4, so run section BGP. (14.1.1) On router 4, router 3, here is the router 3. No, I am talking about router 1 and router 4. Router 1 and router 4. No router BGP number 100. Router BGP number 100 and neighbor 14.1.1.4, remote AS is 500. And on router number 4, yeah, now we have BGP neighborship here. So IP BGP summary. Done. Let me take you to R1 again and say neighbor 3.3.3.3 remote ES is 100, and for this neighbor 3.3.3 I'm going to update source loopback 1. Now show IP BGP summary. So this neighbor 3.3.3 is idle and this neighbor is fine. I have received one prefix here, so IP BGP. Done. It have installed in BGP table. Now it will install it in their routing table as well. So IP dot BGP. Fine. Now let me take you to R3. On R3, router BGP ES number 100 and neighbor 35.1.1.5 and remote ES is 500. Now I am expecting BGP neighborship between P to C here inside 2. Do so run section BGP 35.3 and do so IP interface brief on F0/0 35.5 line protocol is up. Do ping 35.1.1.3. I'm not able to ping. Let me take you to R3 and do so IP interface brief. Oh, IP address is not there. Interface F1/0 say no cert and the IP address 35.1.1.3 255.255.255.0. I'm expecting eBGP neighborship between P to C. Do so IP BGP summary. Done, guys. Here I have received one prefix. Do so IP BGP. So see, I'm running 20 prefix here and do so IP route BGP. So both PE router have customer prefixes, right? Now both PE router need to exchange these customer prefixes with each other. So on router number 3, router BGP ES number 100 and neighbor 1.1.1.1 and remote ES of neighbor is 100 and neighbor 1.1.1.1 update source loopback 1. Now I am expecting BGP neighborship between 1.1.1 and 3.3.3. Yes, we have BGP neighborship, correct? So IP BGP. You can see I have received 10 prefix from which neighbor? iBGP neighbor 1.1.1. That's why router 1 have not modified the next hop. Whenever router advertise prefixes to their iBGP neighbor, it will not modify next hop, correct? On the router number 1, so IP BGP. Yes, here also you can see 10 as well as 20. Why 20 network is not best? On router number 3, 10 network is best. So IP route 14 network is there through OSPF. Actually I have advertised this one link in OSPF. Do so IP do so run and section OSPF. Am I running 0.0.0 command here? No. Interface F0/0 say no IP OSPF 1 area 0. Now on both provider edge router you will see remote customer network will be not best, only valid. So IP BGP here you can see 20, subnet is only valid, not best. On router number 3, so IP BGP you can see 10 network is only valid, not best. Reason next hop. So what I told you in the last class, how to modify the next hop here with the help of route map, correct? So I can tell to router number 1 that bro, whenever you will receive prefixes to 3.3.3, Please set next hop what? 12.2 or 23.2, because these prefixes are already advertised in OSPF. Correct? So what I can do on router number 1, config T, I can create one route map here, and name of route map I can say next hop IP, and then permit, let's say sequence number 10. Here I am saying set IP next hop, and what IP address you want to configure? Let's say 12.1.1.2. Then I can apply this route map with neighbor router BGP is number 100 and neighbor 3.3.3.3 call to route map. Route map name was, this is the name of route map. Let me copy the name, and in which direction you will apply? In direction whenever you will receive prefixes from this neighbor. So now clear IP BGP star soft in. So IP BGP, now you can see 20 network is valid as well as best, so it will install it in the routing table. So IP BGP, you can see it have installed 20 network. In the same way on router number 3 I can create one route map, and name of route map is again here next underscore hop IP permit sequence number 10, and here I can say set IP next hop, let's say 21.1.1.2, exit router BGP is number 100 and say neighbor 1.1.1, call to route map, name of route map next hop IP, paste in indirection, and clear IP BGP star soft in. So IP BGP, now you can see 10 network is valid as well as best. So both PE router have customer subnets. Now question is, can these two LAN users, mean these two sites, communicate with each other? So IP route, do I have 20 subnet? No, right? On router number 5, do I have 10 subnet? So IP route, guys, no. On router number 1, so IP BGP neighbor 14.1.1.4 and advertised route. So see, router 1 is advertising 20 subnet to router number 4. Yes or no? This P router is advertising this network 20 subnet to C router, but C router is not accepting. The reason? They are on AS number. Yes or no? Are you getting my point? Tell me, guys. Hello. Is it clear? Hello. Clear? So what I can do? On router number 5, I can, on router number 4, I can tell to router 4 to receive same AS prefix with same their own AS number, you can say. Whenever BGP router receive update with their own AS number, router will discard it. But we can allow that. I can say router BGP AS number 500 and neighbor 14.1.1.1 and allow AS in. So IP BGP is 20 network there. Yes. Next hop 14.1.1.1, because router 1 is advertising to their eBGP neighbor, so it will modify the next hop IP. Fine. In the same way on router number 5 also I have to allow the prefix. So say router BGP ES number 500 and neighbor 35.1.1.35.1.1.3 and allow ES in. So IP BGP. Now you can see this router have also installed 10 prefix in their BGP table. So IP route BGP done. 10 network on router number 4 on side 1. So IP route BGP 20 network done, guys. Tell me, bro, if everything is okay. Am I audible? Yeah. Clear? Hmm. Now can these two sides communicate with each other? Router 4 ping 20.1.1.1 source 10.1.1.1. Ping is not working. But guys, now I can advertise 10,000 prefixes between side 1 to side 2 with the help of service provider, and even service provider in the service provider network only P routers are going to install the routes. These P routers will not install the routes, and between this P to P there will be multiple path. This is the service provider network like this. But these routers are not going to install the customer prefixes. This is the service provider network, right? Only P to P router, right? We have BGP neighborship here, right? So whatever prefixes this company Dell side 1 is advertising to their PE router, this PE router will directly advertise it to their other PE router, right? It will not advertise to this router or this router to their designated router, right? This is a scenario where we are using BGP. Clear? Now this is a question to you. Why ping is not working? Done, guys. Any question? For tomorrow, we'll do what? We'll design a topology like this. Let's suppose this my company network is this one, like I have one router here, R1, then R2. I'm going to design a good network for my company, a best network. R2, R3, R4. Let's say R5 also, R6 also, right? And this is my router 1. You can also design this topology in GNS3 because we are going to configure this topology tomorrow. R1, R2, R3 and R4. R4. You can assume that we have one router at each building, right? There are 4 buildings in a campus. At each building I have one router. So now we need to connect these all buildings together. So I can connect like this. Scenario can be anything. It can be for building, it can be for offices, it can be for branch. This is the connection. Why we have lots of connection? For the redundancy. And on all routers we are going to create one loopback. If you are not clear with this basic concept of BGP, I cannot make you understand this topology and these types of configuration, guys. Sorry, here 2.2.2. So make sure you will perform the all previous lab by yourself. This is the network of my company. Now I can configure any IGP protocol here. See, I will come with this topology, right? Loopback will be already there. OSPF will be already running there, right? To make reachability between these all loopbacks. This is my topology. And router 5, router 5, router 6. Let's suppose these are the branch at different location. R6 branch at different location. I have connectivity like this here, right? Between router 5 and router 6, I am using any IGP protocol like EIGRP, running EIGRP. And now here, which routing protocol you are going to use? Which routing protocol you will use, guys? BGP. Here also you are going to configure what? BGP. And let's say these external networks are advertising some prefixes 50.1.1.0/24, 50.1.2.0/24, 50.1.3.0/24. Now you will see the real-time scenario. In real time, if you are thinking that task of network engineer is easy, right? They only need to configure the BGP, OSPF or switching protocol. They need to troubleshoot it. How easy it is? No, guys. Now see, let's suppose router 1 is at building 1 and building 1 is connected with 4 floors. Floor 1, floor 2, floor 3 and floor 4. At each floor we have local area network. So what I can do, I can create some loopback here for those floors. 10.1.1.0/24, 10.1.2.0/24, 10.1.3.0/24 and 10.1.4.0/24. You know your requirement can be what? This is first floor. I'm saying first floor. HR people are there, right? In the external network, guys, in this company we have HR department here. HR. Second floor, here we have sales team. Here is the sales team. Now your task can be configure BGP between router 1 to router 5, or your task can be like HR user should communicate via router number 3 or via router number 4, like this or like this, right? Or like this or like this, or guys, HR user should communicate like this. That is what? Path manipulation, right? And this is the reason why we are using BGP. So we have lots of options here for the path manipulation. Okay, we will see how we can manipulate the path in this scenario. Here you can configure IBGP. IBGP. Here you can configure EBGP. Right? And you need to manipulate the path. Maybe you need to configure the failover, you need to configure the load balancing. And there is one very important concept in BGP. To reduce the configuration of BGP, we have one concept that is known as neighbor peer group. Neighbor peer group. Right? Like guys, see, router 1 have how many neighbor? Router 3, router 4, and router 2. How many command you need to run on router number 1? Router BGP AS number 100 is the first command. Then neighbor 3.3.3 second command. Neighbor 3.3.3 update source loopback 1 third command. Neighbor 3.3.3 password Cisco 123 fourth command. Right? So minimum 4 command for one neighbor, right? How many neighbor are there? 3 neighbor. That means 12 command you are going to run on router number 1 just to form neighborship, right? 12 command on router 1, 12 command on router 3, 12 command on router number 2, and 12 command on router number 4. How many total number of commands are there? 48. So if you are going to run 48 commands, guys, there is chance of human error. Human error, yes or no? Is there anyone who is thinking, no, Praful, there is no chance of human error? We can, guys, we can make the mistake here. So to avoid this human error or the effort of network engineer, we have what? BGP neighbor peer group. I can create one group on router number 1. Let's say group name is ABC, and I'm going to tell, I I am going to define some rule here under ABC, right? Like update source loopback 1. I'm going to configure update source loopback 1 in this rule. Like this, I can configure multiple things here in this group, and then directly I am going to apply this rule with all neighbor. Directly I will say, hey neighbor 3.3.3, please apply ABC. Automatically all configuration will apply for that neighbor 3.3.3. That is what? Neighbor peer group. Don't worry, we will see that. Yes guys, any question from today class? Any question? And in this scenario, what you can do? You can assume that router 5 is ISP. Router 5 is ISP. Sprint US. And router 6 is another ISP. May I know the name of any other ISP? AT&T? Let's say router 6 is AT&T, right? So in this scenario, your network, your private network have connectivity from 2 different service provider, right? And guys, both service provider are connected together. As you know, all service provider are connected together. So if both service provider are going to advertise same subnet 50 and 60, right? In that scenario, how we will manipulate the path? How to perform load balancing between these two ISP? How to configure primary ISP, secondary ISP failover in BGP? So I am going to design this topology because this is very, very common topology for the real time. Very common topology. Many time you will see this type of topology in the network. Completely real time topology scenario. And you will see while configuring, we will understand troubleshooting as well. We will have lots of issues here. Okay, so first guys to agenda for tomorrow is, first of all we are going to understand neighbor peer group, neighbor peer group. And let me give you one task. There is a small concept in BGP, that is synchronization rule. So guys, JSON rule. So this is your task. Learn synchronization rule by yourself. If you will have issue, definitely I will discuss. Otherwise, I will ask to you what is synchronization rule tomorrow. Okay? And I am expecting answer from you all guys. Right? So this is your homework, synchronization rule. And my agenda for tomorrow is neighbor peer group. After that, configuring this topology here, path manipulation. Like for that, we will discuss attributes. Attributes. BGP attributes. Most important topics of BGP. Right? Attributes are next hop, then wait, then local preference, then self-advertise, then ES path, origin code, then MAD metric, external over internal like eBGP over iBGP, then IGP cost, to reach next hop, oldest path, right, lower neighbor IP. How many attribute I have written here? 11. So one is more there, that is lower. This is actually the last one, lower neighbor IP address. Before that, we have one attribute, that is lower neighbor router ID. These are the attributes that you need to understand. Clear?